This animation shows the chaos of local development, mismatched node versions, missing dependencies, and conflicting ports, collapsing into a single, perfectly isolated container. Today, we are going to set up your workflow so you can launch a complete NestJS API, along with a database and a cache, using just one command. Before we write any configuration files, you need two things ready to go: an existing functional NestJS project and Docker Desktop installed and running on your machine. Moving your code into a container removes the unpredictable variables of your personal laptop. You get a guaranteed, reproducible environment that behaves exactly the same way here as it will on a production server. Step 1 is securing our build boundary. We do this by creating a .docker ignore file, which acts as our first line of defense to keep the container optimized. This code editor shows our Docker ignore file, and you can see we are specifically excluding the existing node modules and dist directories. If we don't block these folders, Docker will try to copy hundreds of megabytes of unnecessary data into the build context, drastically slowing down the process. Worse, your local node modules likely contain binaries compiled specifically for your operating system. Then we make a deliberate choice. We copy only the package.json and lock files into the container, rather than the entire codebase all at once. By running install based solely on package.json, the dependency layer locks into place. Docker caches this layer, skipping installation on future builds, unless you add new packages. Finally, we copy the remaining application code and run the NestJS production build. Finally, we define the startup instruction. We tell the container to run the main file located in the newly created dist directory to start the server. That precise sequence of commands turns a generic Linux image into a highly specialized, high-performance NestJS web server ready to receive traffic. Now we need a way to manage our server alongside other services. That requires orchestration, so we create a docker compose.yaml file. This editor displays our compose file, and you can see a highlight around the port mapping configuration for our primary API block. That mapping instructs Docker to take the internal port 3000, where NestJS is listening inside the container, and connect it outward to port 3000 on your actual laptop. When deploying behind a reverse proxy like Nginx, a standard security practice is to bind these internal services strictly to localhost, hiding them completely from the public web. With the API defined, we can add a Postgres database or spin up a Redis cache. Docker Compose automatically provisions a unified internal network for all of these blocks, weaving a secure, invisible web between every single container. Your NestJS app can now discover and talk to the database securely, without either one leaving the container network. By defining these relationships in one file, we upgrade the application from a standalone script into a robust, scalable, multi-tier architecture. It is time to turn it on. In your terminal, run docker compose up-build. As the logs scroll by, look for the standard NestJS bootstrap sequence. You want to see the framework initializing and successfully mapping your route endpoints. To manually verify everything is working, open a web browser and navigate to localhost on port 3000. You should see your API's default response. Seeing that response proves the application is fully operational. It is running completely isolated from your host machine, using only the resources we explicitly gave it. This dashboard shows our final state, a fully functional stack containing our API and database, running seamlessly with healthy status indicators. Because the environment is entirely self-contained, this exact architecture is highly portable. It is ready to be dropped onto an AWS EC2 instance without any code modifications. The next logical step in the workflow is automation. You can set up a CI/CD pipeline using GitHub Actions to deploy this container to your server automatically every time you merge code. Running your application in a local container is the non-negotiable first step. It bridges the gap between amateur scripts and managing an enterprise-grade deployment.
Enhance your coding skills with us. Don't forget to subscribe to Code 5 Food for the latest updates and tutorials.